Friend standing next to me. This is his first time speaking at DEF CON. His name is Sheng Hao Ma, and he wants to play with malware injection with exploitive thoughts. I don't know if I said that right, but let's hear him explain it. And before we get started, I'm going to give him a good congratulations. Oh, you already drank?
I already drink. Oh. Okay. So, hello everyone. My name is Ma Sheng Hao, and I'm just a master's degree student from Taiwan. And I'm also a security researcher from Stage Root and TDOH Hacker. This is my first speak on DEF CON, so I'm a little bit nervous, and I just drink that shot, and it's very spicy, so that's okay. So let's do it. So it's the agenda. First, I'm going to talk about what is malware injection. Vulnerability inspired by PowerShell, power loader. So let's quickly review what is malware injection. And in the past, malware injection is used for bypassing some production, like bypass whitelist tracking, bypass antivirus, or privilege escalation. And for example, with DL side loading and digital signature, we can bypass the antivirus. And with remote inject and whitelist process, and we can bypass the whitelist. And with the inject Explorer and DL side loading and self-elevated service, we can bypass Windows UAC production. And then there are several well-known techniques, like we have known about those technology about inject, like shellcode inject, DL inject, process hollowing, and thread hijacking, atom bombing, and memory exploit. And in my presentation, I will focus on how to do malware injection in exploit way, how to do it. And if you want to do a malware injection, actually there are 4 challenges for you will meet. The first one is, what is target? You should choose a good target to injection. And this target must be meaningful. Then secondary, where to place? And a memory space for us to place our malware code in remote process. Then thirdly, we need to know how to write malware code from remote. And finally, we need to find a way out to run the malware code from the remote. This is the most difficult part for us. And you can create a new thread and hijack current thread or whatever. So this is an interesting case for us. We are talking about as power loader. And what is power loader? Power loader is known as extra window vulnerability. So what it is? And there is Windows data in Explorer process memory. And those data decide how your GUI, how your window is look like. And this is how it's going. First, operation system will send messages to your Explorer. Secondary, Explorer fetch the vtable from those data. Finally, Explorer invoke the callback functions on the vtable. And you will say, what's the problem? It seems very normal. It's generally. So what's the problem? The problem is how Explorer fetch the vtable, because we know Explorer will invoke the callback function from vtable. So the problem is how Explorer fetch the vtable. Actually, it fetch the vtable by a Windows API named getWindowLong. So we can easily modify the result of getWindowLong API. Just use setWindowLong API to change the vtable address. So let's put it all together. We can know if we can inject a fake vtable, then we can use setWindowLong API to point the vtable address to the fake vtable. And then we can, if we send any message to Explorer, Explorer will invoke our malware code from the fake vtable. So if you, I give a payload here, and we just prepare our shellcode and prepare our memory layout on that vtable, then use setWindowLong PTI API to modify the vtable address of target, aka Explorer. Then just send a message to that Explorer and we'll trigger our payload. So let's see a quick demo. Here, okay. So, and here you can see, let's test on Windows 7, and here is my shell code. Then it's pretty hard to use big screen. And then you can see I prepare our memory layout and inject the fake vtable into target Explorer and send a message to Explorer. You can see if we compile, and you can see Explorer is crashed and down, and run our shellcode on the remote. Okay, so there are three more vulnerability from we are talking about next. First one is OLE drop enter event, and what it is. And if you do some reversing stuff, you will see like those code on the screen. And Explorer use global add atom to keep a string named OLE drop target interface. This string in the just keep it by global add atom API. Then you can see when Explorer try to register a drag and drop event, you can see Explorer store the drop target structure in OLE drop target interface properties. So, and you ask about what is drop target. This structure is used for what? And you can see drop target is actually it is a vtable class. Keep every copy function address of drag and drop event. So Explorer use, and when you try to drag any files to Explorer or inside Explorer, you will trigger a function named privilege drag and drop. And you can see in this function, Explorer will try to use getProp_w API to fetch the vtable class and invoke the function on the vtable when you drag any files inside Explorer. And you ask about why is the problem. The problem is it's pretty easy for us to modify vtable address by another API is setProp_w. And if we use this API can modify the vtable address. So what we need to do is inject a fake vtable and point the OLE drop target interface, the properties to our fake vtable. So finally, let's see how it goes. You can see drag files. If we drag files inside the Explorer, then operating system send a message to our Explorer. Then Explorer fetch our flag v table by getProperty W API because we just use setProp W API to change the v table address. Then the Explorer will invoke the malware code from our flag v table. So if we need to prepare, if we prepare the our shell code and the v table on the correct memory address, then use setProp W API to modify the v table address of the window data. And whenever just Explorer send or receive any drag and drop event, the message, then Explorer will invoke the malware code of our shell code. So it's the first one. You can see how we inject the drag and drop event of Explorer. Here. And first, you can see it's our shell code. And here, what we need to do is prepare our vtable address, and the vtable address prepare our shell code address. The Explorer will call the function on memory plus C, and we write the process memory, this shell code into the vtable and the shell code into target process. Then just use setProp API to modify the OLE job target interface properties. So you can see if we compile, and we compile and inject the shell code and the vtable into target, and there's nothing happen. But if we drag any file into Explorer, you can see there's a message box there is from shell code. Then you can see we can look it on Test Manager, and you can see it's from Explorer. This message box is pop up from the Explorer. So, so silent. And the second case is COM-CTO subclass event. And first, Explorer keep UX subclass this property string by global add atom API again. Explorer invoke master subclass pros function if it receive any message. If in this function you can see Explorer call the function first get subclass header and to fetch the window data. Then verify the window data we just get by another function is enter subclass frame function. Then finally, if the window data is correct, and Explorer will try to invoke the function on window data. So let's see how Explorer check the window data and how to call the function. And in enter subclass frame function, we just said about it's used for verify the window data is correct or not. So only thing we need to care about is here the vtable plus a, the function address cannot be null. It should be null, or it will fetch the bad memory address and cause Explorer crash. So we need to prepare our vtable. We need to keep it null on the window data plus a. And in enter subclass callback function, you can see the vtable is actually it is dynamic. And so Explorer have a rule. Actually, on this slide, you can see Explorer have a rule to get callback function dynamically in our vtable address. So we can use this rule to check which address is our shellcode address should be put at. And finally, Explorer invoke the address we get just on the window data to process those message, any message. So we just need to prepare another vtable and our shellcode in the vtable address and put it all together on the correct memory address. Then just use setprop API to modify the vtable address and just use send message to trigger a message function of Explorer. This is another more interesting case here. And you can see it's Meta Explorer I built on my PC and it's finished and Windows Defender is open. And I just took this video yesterday. And whenever I just click the POC, and you can see that there's nothing happen for user. Victim don't see anything there. But our Meta Explorer here is get a reverse share. And we can do anything like ls, system info, and even we can execute a CMD. You can see Windows Defender is not happening any all, not protect us. And you can see the CMD is come from Explorer. Okay, so the final interesting case is threat hijacking is this case is those vulnerability code is inside the Windows 10. So if you use Windows 7 and Windows 8, you are safe. Yes, it's pretty ridiculous. And every process is created on Windows operating system by that API is create a process, this API. And the kernel will create a new process and map each session into the new process memory. Then create a new thread, then point the PC register to the program entry, aka address of entry. And first, threader didn't just jump into the address of entry. First, threader will call the LDR initialize thunk to repair the import address table, export directory, and relocation information. And the interesting is, you will see now, for now, threader should just jump into the address of entry, right? But no, for Windows 10, threader will check variables is before threader jump into the program entry, every threader will jump into another address is address of LDR dedicated RTL user threader start these variables if it's not null. So if it's not null, and just jump into it. So you can see it's pretty easy for us to abuse. So just put a shellcode to the target process and write a shellcode address into LDR dedicated RTL user thread start this vulnerability. Oh, its name is very long. And every thread must jump into the shellcode address if it's created on the new target process. So let's see the final demo here. Here, you can see it's Chrome, and I open a new Chrome there, and here I just only thing I need to do is to get the actually LDR dedicated RTL user thread start is located at which address. And when we get the address, and we just write our shellcode address into the variables, then if cron, you can see I just inject the shellcode and the variable on the target process, and nothing happened there. But if we try to browse a new website like google.com, and you can see there's the CMD come from Chrome. Yeah, thank you. You can see this CMD is come from Chrome. So, okay. So, thank you for listening.